the title of my presentation is The Language of Science, Young Learners, Scientific Literacy and Cultural Models. This is a little bit of what I presented before in another conference. It's because the others isn't exactly the same. I'm going to repeat some of those ideas, but I'm also going to introduce a few aspects of discussion which might seem very basic, but might trigger a bit of thinking of what we can do and how to go to schools and manage our expectations ourselves. And this is the product of some reflection I have together with Tim, and yeah, so pretty much what the presentation is going to be like. Let's see if I can do the next slide. Yeah. So this, I'll briefly introduce myself. I'll talk a little bit about scientific literacy and culture for learning. Then this is the new bit, languages and science. What can you do as our first approach, and then I'll conclude. I am a native speaker of Portuguese. I speak English too, Spanish, bit of German, bit of Italian and French, all European languages. I've been a researcher in the UK, in Spain, in Italy and in Belgium. And I taught science. I taught chemistry in secondary schools, maybe 3 across the UK. So the aims of this presentation are to show how a good understanding of languages or how words are made can support with learning science, to show how culture and cultural preferences has a strong influence in learning science, and how to approach practices of learning languages and science. And this last point is the really new one. So let's start with scientific literacy and culture for learning. So my first point is how, and this part of the presentation inspires itself quite a lot on a document from published by the Education Endowment Foundation. And one of the points is during my teachers training, etc., and for lots of teachers, teaching science is also about teaching languages and making meaning of foreign words, and photosynthesis is a good example of it. Now, if we're trying to make a lot of complications about explaining a concept, etc., it's a lot easier to go to the root of the words, to their structure, and to their origin. So structure, morphology, and the origin, the etymology. And the vast majority of the foreign language or the foreign words we need to learn are made of prefixes and suffixes, and they repeat. And we just need to make sure our students understand it and understand it systematically. So a good example is photosynthesis. Photo derives from light in Greek. Syn is about putting things together. And thesis is about setting or putting or placing. So yeah, putting things together. And this is just an example. Another good example are units. I can remember, for instance, meter. From meter you can form things that are 1,000 times a meter, kilometer, 1,000 or the 1,000 divided by 1 meter divided by 1,000 millimeter, and so on and so forth. So this is all about understanding a language which is not necessarily familiar to students, and this is why I think that teaching science has got a little bit to do with teaching languages. And another good example of that has got to do with my own experience is that this one on the right side of my slide. Yeah. So one of the difficult things is that I remember. Oh, sir, what's the it's not the cycle of carbon or something like that. I remember. So our colleagues in geography will be teaching something. And teaching definitions of climate change. That's the thing. Definitions of climate change and global warming. And in science, we'll be teaching something else, and that might prove to be difficult. So linking subjects with different meanings might get young people confused. Okay, and false friends also happen quite a lot. In chemistry, we've got a very good example of a confusing word, which is, or two expressions, which are hydrocarbons, which are molecules that have got only carbon and hydrogen, and carbohydrates, which are very similar in a way. They contain carbon, oxygen and hydrogen. and they are very similar chemically too. Well, not very similar chemically. There are lots of differences between both of them, but the words might be misleading. And they are, I would say, you just split the order of the word in a way, and they're very similar. There might be confusions over there. Now, another good example of a student who told me, "Sir, are you talking about a lettuce?" No, it was a lattice. Maybe also to do with my pronunciation, but yeah, a student asked me that, and yes, it can be confusing for them. Another one asked me, "Why is there an avocado in the corner of the slide?" And I said, "Well, because you need to learn how to pronounce it properly." This man was Italian. He had a name. It wasn't an avocado. And yeah, sometimes it's useful to make these things more explicit for students. A very interesting concept, but not so useful for me, that I never used as a foreign or native. So my native language isn't English, and I've been advised to use something called the Freya model. Which is kind of a word cloud, and you put things together. I just needed to memorize things, and it was a lot easier for me. But some teachers use this in order to make meaning of words, and they use them as, for instance, conceptual maps, and that seems to help students relate, putting things together. Now, something very important, and the level at which we are teaching in science has to do with tier 3 vocabulary. Okay, so the words become increasingly difficult to understand. So we are teaching at that level, not all the time, but there will be terms that there will be lots of tier 3 words that we need to teach, and this is what makes teaching the foreign language, which is science, so difficult for secondary school students in my case, when it was. And we need to also to be aware of the cultural level of families and the way students speak on a day-to-day basis, and it helps to make speech and answers more elaborate. Now, the key idea is there will be an exam where they need to mention a word which is a magic one, and if they don't get the spelling right, they might get they might not get no marks. I'm thinking, for instance, about temperature. It's very easy to spell it wrong, and sometimes they will not get the marks because of that. So they need to be aware of all those tier 3 words. Another important aspect is giving students an idea of strategic reading. It's not necessarily related to learning language, but it's about how to read a paper, or how to read, not necessarily a paper, but how to read a text. And actively reading and reading for information is something that is highly recommended in order to find those words and seeing them written. And it helps answer words, and it helps to interact with other students with the same level or with higher levels of knowledge. So it's all about strategic reading. It's all about having a prior knowledge, challenging that knowledge, being able to predict things. My daughter at primary school is doing that right now. So being able to predict, asking and actively engaging with a text, and being able to understand it. So that's the important thing. So questioning, clarifying, and summarizing are skills that are useful, and they are useful for language learners, and they are useful for science students. Now, the disciplinary literacy, and this is very specific to science, I would say, also to languages. Disciplinary literacy is all about speaking and writing with a purpose, writing in full sentences that are fully understandable, that are not too informal. Disciplinary literacy is also about extracting relevant information and being able to summarize it. It's about creating rich oral and written language environments, and this is key, in my opinion, to language learning. I remember my language lessons a while ago. I think that last language I've learned formally was German, and the teachers were actively looking for that. And that is common, creating a rich learning environment in which students are able to speak and to use the correct words, it's something really important for both subjects, I would say. And then providing opportunities to hear, read, and use new words is also key in order to develop this disciplinary literacy in science and in languages. So that could be via role play, that could be via working in a practical, for instance, in science. I can remember now. It could be a debate, a plenary, something like that. And those techniques are very well present, and they are very well known in schools. Now, another key point is that one over there. The cultural capital, and science, in my opinion, is culture, and it's key. Scientific culture is key for everyone, and for society to progress. Now, it's the cultural capital. It's an idea proposed, or a concept proposed by Pierre Bourdieu, a French theorist of these things. Cultural capital is what allows people and societies to go over their limits. It's all about those opportunities that are present in our daily lives, the films we watch, the museums where we go to, the traditions we celebrate. It's all about understanding and in many ways being human and being able to progress as a society. Now, all this relates to our previous knowledge and to our ideas, to our preconcepts, let's call it like that. And in science, our culture in science is pretty much related to what the Greek and the Latin civilizations or the languages give to us. I'm thinking, for instance, about systematics in biology. I'm thinking about the origin of words. There's lots of Greek and lots of Latin, so it helps to know a little bit of Greek, know a little bit of Latin in order to understand science a little bit better. And then there's the presence of French, German. There's also Arabic and Chinese, I would say, for historical purposes. But for instance, Chinese, there are lots of journals in Chinese right now. And German has been traditionally a language in science too. Now, our students will, if we consider that previous knowledge, they will have conflicts, and they will have alternative ideas or misconceptions. So this clash is something to expect, and it's something that can be seen as an opportunity. But we need to be ready for that, and that's an important point. Now, talking about this cultural capital is something that is really present in schools right now as a concept. How do we work with this? We go out of school, we do visits, etc. And Ofsted is pretty much focusing on this. How do schools create, give opportunities for students to enlarge their views, their horizons in life? Cultural capital, definitely. That's what this is all about. And these ideas we're discussing are very valuable for a school, for any school, I would say, to say, oh, we're extending our curriculum, we're making something very relevant over here. We are helping our students understand better the world that is around them. So this unlikely link between languages and science is something that I would say can be very appreciated by any school. Now, how can we approach this? And this is product of my conversations with the team. I'll take a very simple approach. I'm sure the audience will have different perspectives. It might even sound simplistic, but I'm going to go for it. So we need to go back to basics. And if we're going to a secondary school, I imagine my students, so I'm going to be there saying exactly the same I'm saying to this audience right now. It's not going to work. So and something I remember very well is the difference between learning a language in my secondary school and learning a language in my language school, let's say. And the approaches are very different. School had to do with curriculum and following the guidelines. Sometimes teachers would speak in Portuguese. I can't remember any of my teachers speaking on a day-to-day basis in my language schools. In the language of the country. So while I was in Spain, I was learning German, and it was really awkward to me listening to my German teachers talking to me in Spanish. I was even surprised about that. So we need to be aware of that, and the vast majority of secondary schools in this country, in the UK, that they teach languages in English, which is odd, but we need to be aware of that. Students will have very little skill of the language they're learning. It's a little bit, for instance, in French, learning verbs will be a little bit like times tables. It will be a bonjour and hello, how are you doing, etc. And that's pretty much how it might be. So knowing what to expect. Now, we don't need to miss opportunities. And there are wonderful opportunities over there when we're talking about units, when we're talking about names. Oh, this is important. This is for a foreign language. This is the origin of the word. And all those links can be made across the curriculum in any school. We will find students with very low levels of confidence, let alone adults, and it's okay to make mistakes, and it's okay to play a game in which the language skill that is required is very low. So that approach will definitely boost will increase the chances of having a successful interaction in a secondary school in the UK. Now, schools have got schemes of learning, they've got learning materials, they're familiar with them, and there will be cross-curricular opportunities, as I mentioned. And it will be unlikely to find a language teacher or a science teacher who can obviously see the obvious link, but there is a link, and there is an interesting link, and we might be able to get there in a very easy way. Now, I'm presenting a case here, teaching the name of lab equipment in French. It can be a sticker game, trying to put them together, and listening to someone talking about it, putting a video. I mean, generating the teaching the lesson, I would say, and then matching names with objects. I remember that when I went to Belgium, this was very difficult to me, and it was in French, not in Dutch. I remember that fiole was something very difficult for me to find out. Verre de montre was another one. Pisette was a very funny word for me to learn, and I can't remember anything else that made me laugh. No. But it's a good example. So a matching game could be an interesting approach for any language teacher or for anyone trying to make a session in a different language. We should not be waiting for students to be able to do a complete lesson in a foreign language, and that's more or less what I mean. Another good example, very basic, hazard symbols, but in German in this case. Again, a matching game could be another example. Of trying to get these together. I think that the vast majority of the secondary schools teach French by default, some German, and sometimes Spanish. But this type of approach could be very easily used and very well understood if you want to, for instance, prepare a teaching kit in a foreign language. Other cases, interesting cases, more related to the cultural capital, and I remember Tim had very good ideas about this. The names of the elements in the periodic table, there are wonderful opportunities over there, let alone the names of the elements in every single language, because every single language has got different names because of different origins of words. Some are Latin, some are German, and that's really, really interesting. Now, the Haber-Bosch process, it's all about producing ammonia from nitrogen in the air. There's wonderful and interesting narrative that we can build around, for instance, chemistry for the good and the bad things, because Fritz Haber himself was a bit of a character historically. And he's done lots of interesting things that we can talk about. So that there could be an opportunity over there to increase students' cultural capital in German, I would suggest. Boyle's law, for me, was always Boyle's Marriott's law. there's an opportunity to talk about two people finding out the same, having reached the same result at the same time. So Boyle found out something that Marriott found out at the same time too. So there's an opportunity over there. And the principle of Le Chatelier is also a very interesting thing to talk about. A very good opportunity for students who are probably more confident. It's for higher tiers. It's only taught at higher tiers of learning. Typically, students who perform better in science, they will perform better in languages. I'm thinking just putting the words in order of Le Chatelier's principle. It's very there should be a very well-defined order, and that could be an opportunity over there. Trying to keep it simple, but not trying to dumb it down too much. And there is science and there is language over there. So to conclude, I think that learning languages helps making meaning of new words in different subjects, and that's really interesting. Maths has got a very close relationship to any of the sciences. And yeah, we learn about meters in both, or surface areas, I can remember, in both subjects. Making meaning of new words generates familiarity with relevant cultures and creates opportunity. This is all about the cultural capital, and this is all about understanding the world in a different way. And science, because of its international character, is a very interesting way to get there, and so are languages. Now, the last thing is that good planning and simple approaches will provide solid foundations to the learning processes we are trying to discuss today. Thank you very much. I hope I didn't get too far on time. Thanks, everyone.
Well, thank you very much, Luís.